ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಸೊ ಇದನ್ನು ನಾವು ರಿಯಲ್ ನಂಬರ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳೋಣ. ಸೊ ವಾಟ್ ಈಸ್ ರಿಯಲ್ ನಂಬರ್? ಆ್ಯಕ್ಚುಲಿ ರಿಯಲ್ ನಂಬರ್ ಇಸ್ ಎ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ರ್ಯಾಷನಲ್ ನಂಬರ್ ಆ್ಯಂಡ್ ಇರ್ರ್ಯಾಷನಲ್ ನಂಬರ್. ಓಕೆ, ಸೊ ಕಾಂಬಿನೇಷನ್ ಆಫ್ rational and irrational number. Otherwise we call this is a set of rational and irrational number is called real number. We already learned in our lower classes in 9th standard. So what is rational number, what is irrational number? So what is rational number? So rational number is a number we can write in the form of p by q, where p and q are integers and q not equal to 0. Okay, so every number we can write in the form of p by q, where p and q are integers and q not equal to 0 is there, then it is called rational number. So then what is irrational number? For example, so 2 by 3 is a rational number. Okay, so 5 by 7 is rational number. Okay, so what is irrational number? So the number we cannot not in the form of p by q, where p and q are integers and q not equal to 0. Okay, for this one example we can write root 2, so root 5. So it's the example for irrational number. Okay, so real numbers is a set of a rational number and irrational number. Both the numbers eradu kuda idre, so that numbers are called real numbers. Okay, so in this class we are going to discuss about the more facts about the real numbers. So in that one, so first concept is, okay, so prove that it is a irrational number. Prove that it is a irrational number. That means we have a irrational number, so that one we have to give the proof for the irrational number. So in that one, in the real numbers, the first concept is prove that root 3 is an irrational number. Okay, so prove that root 3 is an irrational number. How to prove the root 3? We all know that root 3 is irrational number, but so every statement, so we need a proof. That's why, so we have to prove that root 3 is an irrational number. So how to prove that it is an irrational number? So we prove this irrational number by contradiction method. That means, so we assume that, okay, so what is the first step? So assume that root 3 is a rational number. So we going by, so contradiction method means reverse process ಅಲ್ಲಿ ಹೋಗ್ತೀವಿ. First we going to prove that root 3 is a rational number ಅಂತ prove ಮಾಡಕ್ಕೆ ಹೋಗ್ತೀವಿ. Okay, so root 3 is a rational number. Okay, so now only I told, so what is that? So every rational number we can write in the form of p by q. Therefore root 3 we assume that rational number, so therefore we can write in the form of p by q. So root 3 is equal to p by q. So we can write in the form of p by q, where p and q are co-prime. So co-prime means, so the common factor of p and q has only 1. Okay, so that means common factor of p and q is 1 only. Okay, so that's the meaning of co-prime. Okay, so now we assume that root 3 is a rational number, so that's why root 3 is rational number. So rational number we can write in the form of p by q. So in that one there is a condition, p and q are co-prime. Co-prime means they have a common factor only 1. Okay, so now squaring on both sides. Squaring on both sides. So what we get? So root 3 square is equal to p square by q square. p square by q square. Here square and root are cancel. We get 3 is equal to p square by q square. So cross multiply, we get 3q square is equal to p square. 3q square is equal to p square. Okay. So is this line stated that so p square is a p square equal to multiple of 3. Multiple of 3. So therefore p square is divisible by 3. So this statement stated that okay, so p square is equal to 3q square. So 3q square is a multiple of 3 agutte. So then p square is divisible by 3. Then the square number is divisible by 3. Then the square root is also divisible by 3. Therefore p is also divisible by 3. P is also divisible by 3. So this implies okay. So p is divisible. The number p is divisible by 3, then we can write p is equal to 3k. P is equal to 3k. K is some constant, okay. So you can take any number 1, 2, 3, okay. So p is divided by 3, and then p is equal to 3 into k. So here also squaring that one, we get p square is equal to 9k square. P square is equal to 9k square. But we know that so here p square is equal to 3q square. 3q square. So this p square is equal to 3q square. So here is there. Okay. So then we can write 9k square. So we can divide. So 1s are 3s are. So therefore we get q square is equal to 3k square. So this implies here q square and q same as it is p square and p. So here q square and q is also divisible by 3. Divisible by 3. So this is contradiction. Why it is contradiction? We say that p and q are co-prime. They have only one is the common factor. But so in this one, in this case, so p is divisible by 3 and q is also divisible by. So p and q are divisible by 3. P and Q are divisible by 3. So this is contradiction. Okay. So this is contradiction. So this is wrong statement compared to this one. Okay. So here we say that P and Q are co-prime, and here we say that P and Q are divisible by 3. So at a time, so both the cases are not possible. So that's why this contradicts to our assumption. Okay. So what is our, it is considered to our assumptions. So what is our assumption? Root 3 is rational. Root 3 is rational. So this is wrong statement. So therefore we conclude that root 3 is irrational, is an irrational number. So root 3 is irrational number. Okay. So I think you are understand. So what is that? So prove that root 3 is an irrational number. So for that one we have to assume that root 3 is a rational number. So every rational number we can write in the form of p by q. So therefore we assuming root 3 is also rational. Therefore we write root 3 is equal to p by q. Okay. And here p by q are co-prime. Co-prime means they have a common factor only 1. Okay. So here squaring on both sides. So we get root 3 square is equal to p square by q square. Okay. Then 3 is equal to p square by q square. So cross multiply this one, we get 3q square is equal to p square. So then we conclude that p square is a multiple of 3 because this is equal to 3q square. Okay. Therefore p square and p both are divisible by 3. Okay. If the square is divisible, then square root is also divisible by 3. Then so we write that one p is equal to 3k. Okay. Because p is a factor of p is a divisible by 3, then it is equal to multiple of 3. Then so squaring on that one, so we get p square is equal to k square, and p square is equal to 3q square. That one I substitute there. Okay. So 3q square is equal to square root 9k square. So 3 1s are 3 3s are, we can cancel. So then q square is equal to 3k square. Here also the q square is equal to multiple of 3. Therefore q square and q both are divisible by 3. So this is P and Q are divisible by 3. Okay, so this is contradicts to our assumption. What is that? So here P and Q are co-prime. P and Q are co-prime. Therefore, here P by Q is equal to root 3. Okay, but it is our assumption wrong over there. So that is root 3 is rational. Therefore, root 3 is irrational number. Like that we solve it. Okay, so this is important for 3 marks questions. Okay. 3 marks they will ask in your examination, they will ask for 3 marks. There is an importance. So like this, so we have so many irrational numbers. For example, so root 2, root 5, root 7, root 11. So we are proving this one also, same procedure, same method only we are proving all these irrational numbers. Okay, so here just change the number and we get the answer. Okay, so I show you the one, so how to get done. Okay, so here instead of root 3 we write root 5. So same statement. Okay, so prove that root 5 is a irrational number, and here we change this root 3 into root 5, then assume that root 5 is a irrational number, so then it is changes to, so then we taken root 5 is equal to P by Q. So same procedure, P and Q are co-prime and common factor P and Q is 1 only. Okay, and here also squaring on both sides we get 5. Okay, so here instead of 3 we get 5. 5 is equal to P square by Q square, and here we get 5Q square is equal to P square, and here we write P square is divisible by 5 and P is also divisible by 5. Okay, and so then P is equal to multiple of 5, so then this is equal to squaring madre we get 25. So here we get 5 and this is 25. So 5 ones are 5, 5s are, so then we get 5. So here it just changes to 5. Then divisible by 5. So assumption is wrong. So therefore 5 is rational number Allah. So we can write 5 is irrational number. Okay, so the same procedure is follow for every number, root 2, root 7, root 11, like that we can follow the every number. Okay, so next we go to another type of question, same in irrational number. So we have another type of questions. And this is as per only 2 marks questions. Okay, so prove that 7 plus root 5 is an irrational number. 7 plus root 5 is an irrational number. So how to prove this is a irrational number? Okay, so here we can look at that there is a rational number. 7 is rational number, addition with irrational number, then it is also a irrational number. Okay, how to prove this is a irrational number? So here also we can follow the same rule. Okay, so assuming method. Okay, so assume that 7 plus root 5 is a rational number. It's a rational number. It's a rational number. Okay, so then 7 plus root 5 is a rational number. Okay? So then we conclude that so 7 plus root 5 is equal to P by Q. 7 plus root 5 is equal to P by Q. Okay, so then root 5 we leave it as, so 7 taken to right hand side, so then it become minus 7. Okay, so in the left hand side you have root 5 and in the right hand side you have P by Q minus 7. Okay, so this one we can make it cross multiply, so what we get, so P minus 7Q divided by Q, we get like this. Okay, so we know that we already in the last section we proved that root 5 is irrational number. Okay, so that is root 5 is an irrational number. Rational number, and P minus 7Q divided by Q is rational number. Is rational number. So this is not possible. So the rational number is not equal to irrational number. So this is contradicts to our assumption. our assumption. So what is our assumption? So root 7 plus root 5 is rational number. Rational number. So this is contrary to our assumptions. What is our assumption? So 7 plus root 5 is rational number. So therefore we can conclude that 7 plus root 5 is irrational number. Irrational number. Okay, so you understand. So first you have to assume that 7 plus root 5 is a rational number. So we taken every rational number we can write in the form of p by q. Therefore 7 plus root 5 is also we can write in the form of p by q. So then root 5 you have to leave here LHS. Okay, so then 7 sent to right hand side. So then p by q minus 7 is equal to p minus 7q by q. Okay, so here we already proved that root 5 is a rational number. Okay, so the number, so inside the root is rational except the square numbers agutte. So therefore root 5 is not a square number. Therefore root inside the root 5 is there, so it is a irrational number. But other p minus 7q divided by q is a rational number. So here rational number is not equal to irrational number. Rational number is not equal to irrational number. Therefore this is contradicts to our assumption, that is 7 plus root 5 is rational number. Therefore 7 plus root 5 is irrational number. Okay, so like that we get another one type of number. So what is that? So prove that so 3 minus root 2 is an irrational number. Prove that 3 minus root 2 is an irrational number. So here also we have to follow the same rule, but small changes is there. So assume that so 3 minus root 2 is rational number. Rational number, and we can write in the form of p by q. So 3 minus root 2 is equal to p by q. So here observe, okay, so here we have positive value, so that's why, so root 5 we can kept in the left hand side, but here we have a negative value, so minus root 2, therefore we shifted the square root number to right hand side and they taken the p by q to left hand side, so then it become 3 minus p by q is equal to root 2. Okay, so there is a slight changes. Okay, so then it become 3q minus p divided by q is equal to root 2. So same for so here root 2 is irrational number. Root 2 is irrational number and 3q minus p divided by q is rational number. Rational number. Rational number. So this is contradicts to our assumption 3 minus root 2 is a rational number. So therefore it is our contradiction to our assumption. So therefore 3 minus root 2 is an irrational number. So this is another type of questions they will ask in your examinations. Okay, so 7 plus root 5, 3 minus root 2. So this type of questions as they will ask for 2 marks. Okay, so next we are going to another type of questions. So this is another type of question. So prove that root 2 plus root 3 is an irrational number. Is an irrational number. Okay, so here also we can same procedure follow for every rational number. So assume that root 2 plus root 3 is a rational number. Rational number. Okay, so you assume that root 3 is a rational number, so therefore we can write in the form of p by q. P by q. Okay, so here squaring on both sides. So what we get? So root 2 plus root 3 whole square is equal to p by q whole square. P by q whole square. Okay. So here root 2 plus root 3 whole square is equal to p by q whole square. So this one we have to expand in the form of a plus b whole square. Okay. So what is a plus b whole square? So this is equal to a square plus 2ab plus b square. So like this two we have to expand. So we get root 2 square plus 2 into root 2 into root 3 plus root 3 whole square is equal to p by q whole square. P by q whole square. So here square and root are cancel, square and root are cancel. So we get 2 plus 3 is equal to 5 plus 2 into root 6. 2 into root 6. So is equal to p by q whole square. Okay. So then, so this one we kept as it is. So p by q whole square minus 5. Minus 5. So 5 sent to right hand side. So then we got, so 2 root 6 is equal to, so we can write, so p 5 p square minus q square divided by q square. 5 p square minus q square divided by q square. So cross multiplying that one, sorry. So this become 5q square. 5q square. So then we get root 6 is equal to p square minus 5q square divided by 2q square. So this 2 comes to denominator. So then we conclude that here root 6 is irrational number. Root 6 is irrational number, and so p square minus 5q square divided by 2q square is rational number. Rational number. So this is contradiction to our assumption. So what is our assumption? So root 2 plus root 3 is rational number. Okay, so this is contradiction to our assumption. So therefore root 2 plus root 3 is an irrational number. Rational number. So like that, so we can prove the, so today we discuss about, so 3 type of questions. Okay, so one is root 3, another one is 7 plus root 5 and 3 minus root 2. So this is another type of questions, root 2 plus root 3. So like this we can prove that the irrational number is an irrational number anta prove ಮಾಡಬಹುದು. So thank you. So we can solve the another type of questions in the next class.